Okay, something in happening. Okay, there you go. So in-vehicle software rollouts using Symfony and uProtocol. That's actually really exciting because we are combining two projects here. So stage is yours. You have.
Okay, this will be a rather technical presentation, so stay with me. But I cannot really give in-depth introduction to everything. So a certain level of understanding of the technology is assumed. If not, you're free to ask, but I need to go through that because I also want to showcase something at the end, a little demo, if that works. And yeah, I want to have time for that as well. So the original problem that we started with was the question how to deploy firmware to custom ECUs. And in particular, the SDV working group member Cummins asked us, how do we deploy our firmware to our ECUs and the engines that we have in the field? And so the usual way to do that is you have a backend runtime system, you have an in-vehicle high-performance computer where you have a component, and then you have the ECUs, and you have an orchestration system in the backend running that is capable of identifying what firmware needs to go to what ECU type and whatever. And then in the vehicle, you have a little software component running that is provided by Cummins that contacts the backend system, gets the firmware image, and deploys it or installs it to the firmware using a proprietary arbitrary way or whatever. We don't really know. So what they asked us was, isn't there a way for us to do this in a more standards-based way? And given the fact that we are now in this community and we have projects like Eclipse Symphony and Eclipse uProtocol, the idea was, hey, can't we use those two things together in order to do that? So for those of you who are not too familiar with Symphony, and Haishi is, I think I am a little, but if I get this wrong, please raise a hand and correct me. So Eclipse Symphony is basically used to deploy a solution to a target. And this is strictly logically speaking. A solution is made up of a number of components. Components can be anything, containers, processes, descriptions of, I don't know, landscape, you name it, doesn't matter. And then you deploy this stuff to a target. And the target can also be any kind of runtime environment. Again, strictly logically speaking, it's an abstraction. It can be a PC, a Kubernetes cluster, it can be your car, a door, whatever. And the target can also consist or have some components which basically represent some infrastructure running on that environment that is needed to provide the service that it does. So based on that, you can say that now this tries to mimic some UML semantics. You have a Symfony API component that uses so-called target provider components to deploy artifacts, which are components, to runtime environments that are targets. There are a certain number of native providers that come with Symfony. For example, the script provider, the Helm provider, and numerous others that can be used to do some standard stuff like running a process on an operating system or deploy containers to Kubernetes. Using this, for example, you can use it to spawn a process. You could use the script provider, which can be configured with the name of a script that you have written yourself, for example, in a bash script or a PowerShell script. And then it can run the script, and the script can do whatever you want. For example, it can spawn a process or terminate a running process. For a Helm chart, it looks very similar. You use the standard Helm provider, which is configured with a Helm chart that you want to deploy, and that uses the Kubernetes API to install the chart and spawn up the containers. So in order to use this for deploying this custom firmware, it could look like that. You have a custom firmware update provider that you implement, custom built, according to the API that Symfony requires you to implement. And then you can basically do whatever you want. In particular, you can contact your backend system, download the firmware, and install it to your ECU in your usual arbitrary proprietary way. But that is not really what we want to do, right? So enter Eclipse uProtocol. Eclipse uProtocol is basically providing a kind of a service mesh that you can use to implement so-called U entities that run on different operating systems and that can then interact with each other using different arbitrary message exchange patterns like publish, subscribe, RPC. You can use different transport protocols for that. Some of those are listed here like Xeno, Binder, SumIP, MQTT. And this can, of course, run on different operating systems. The idea, so in the end, is that you have an abstraction of all of the underlying technology. You provide the service mesh and use a logical addressing scheme from the client to the server to interact with each other. So what does that mean now for the overall problem at hand? The idea now is to implement a generic uProtocol target provider at the lower left. So this would be based on Symfony's Rust binding, which the good folks from the Symfony project have just completed. And this uProtocol target provider would then rely on the uProtocol mechanism for invoking a remote U service. And this needs to be implemented only once, of course, because it is using the standard uProtocol API in order to interact with a service. And then in the middle, this is the more interesting part, we define a generic target provider as a U service. In uProtocol parlay, that is basically an interface description. And we use an IDL to define the operations very much alike the operations that the target provider interface of Symfony defines. And then we only need to implement this generic target provider U service interface with our components. And out of the box, the provider can talk to our custom target provider. Then the target provider, the uProtocol target provider, only needs to be configured with the logical address of this component, the uProtocol URI usually, and then the whole system should work. So the idea then is to really implement this like pointed here, have a custom target provider that then installs the firmware on the custom ECU. So logically, what I have done in the POC is I created an engine firmware solution that consists of two firmware components. Those are basically just strings. It's just a name for the ECU that it should deploy to and a URL to download the firmware image from. I created an instance with no name, doesn't really matter, and I created a Commons engine target, which basically is where the firmware needs to be deployed. So in its physical manifestation would actually be the real engine with its ECUs. But in this case, it's just a logical deployment target that is used to interact with in order to really deploy the firmware. And the engine target, interestingly, has this ECU updater as a component itself. That is the implementation of the target provider, which Symfony needs to interact with in order to trigger the download and the installation. So this whole thing then is a two-step process. The first is we use Symfony and the script provider to start up the ECU updater process. That is done using the script provider and a bash script that I have written. That you will see later in the demo is the first step that is being done automatically by creating the target, the logical target in Symfony. When you do that, you configure it with all the necessary information to start it up. And then later, the second step is to actually install the firmware, and that is then using the uProtocol provider, which invokes the ECU updater that we have started beforehand by the script, and that then installs the firmware. So I have implemented this ECU provider in a very trivial manner. It basically just is a protocol handler. It takes the requests that come in from Symfony and then logs a line what it is supposed to do. Like, for example, now I'm installing the firmware, blah, blah, blah. Now I'm deleting the firmware, blah, blah. So, and that is what I hope I can now demo to you. There we are, there we are. Okay, so here in this window, I have started up the Symfony. I've started up the Symfony API. And the first thing I'm now doing is I hope I can create the target, the logical target. And what this does is it spawns up the ECU updater. And that is done by defining this target with this component configured on it. And the ECU provider is using the script provider that comes with Symfony. And these are the scripts that I have written that are configured now for it. Now, if I send this, I hope that we can see something happening here. So this is what the script output, starting the ECU updater. And the ECU updater service is up and running. So that's that was the first step. Now the second step is to create the solution. The solution consists of two firmwares. And these firmwares are of type Commons firmware. And this type here is used to match it to the correct target provider that is running in Symfony. And if I now send this, we should hopefully see something happening, but we don't. Oh, no, not yet. That is just the logical creation of the solution. Now we need to create the instance which associates the solution to the target and therefore triggers the installation. So that would be the instance here. So this refers to the solution and the target. And now let's see and hope. And here you are. Now this has been processing the request from Symfony to actually deploy the firmware. And this process is now, being watched all the time, meaning that if the firmware were not a firmware, but for example, a program that needs to run all the time, and if that program would be killed, then Symfony would see that it got killed by doing these GET requests and polling the current status and respawn these processes all the time. So what had been working yesterday or last week was that I can now also delete this instance and see the components being deinstalled, but that did not work yesterday. Let's see if it works today. Oh, it does. Okay, removing the firmware there. That's the other way around then. And this way you can basically assemble all your stuff. And what this now does, or what this provides us now, is instead of implementing all this stuff in a proprietary from scratch, dealing with the communication layer, the security, how RPC works and stuff, you can really focus on implementing this target provider logic somewhere and simply reuse all that we have done in uProtocol and all that is done in Symfony and really put this together very quickly. So the simple implementation that I have done, which does not really do the installation of the firmware, but that is effectively, that is 30 lines of code, right? Because that is all built on top of the existing stuff. So that's where we currently are. That's the POC. I hope to contribute that to Symfony during the next weeks. That is once our internal clearance process has allowed me to do so. But yeah, that can only be months. I don't know. Let's see. Yeah, so that was all that I wanted to show. Are there any questions? Ansgar.
Hello. Yeah, I'd have one which I believe I have maybe parts of the answer already in head. But Kai, you mentioned that Cummins wanted to change that system to a more standardized way of updating firmware. And you mentioned that they have a running system in place, which is doing their updates today. So just doing it in a little bit more standardized way is maybe not motivation enough. Just doing different tech because you can is maybe also not motivation enough. So why are they looking into that?
Well, the key is the standards-based stuff. So the hope is that whatever architecture we come up with or whatever this working group is building in the future will be so successful that it becomes a de facto standard in the trucks that they deploy their stuff to or they need to install their stuff to. And then for them, it will be much easier to simply hand out the firmware updater U entity to everybody instead of having to adapt it to each and every customer that they have, right? And their IT setup. So that's the whole idea. It could be any other standard as well. It's not particularly interesting to do it like that. It's interesting to do it in a standard way that has a chance of becoming a de facto standard, I guess.
That makes sense. Thanks.
And by the way, as you mentioned it, they have the logic to install the stuff. All they now need to do is wrap it with the uProtocol protocol handling, which is very easy to do. So for them, it shouldn't be much work to actually migrate.
Any other questions?
Thank you very much. Just have a question concerning slide 8, if you can.
This one?
Yes. What is the difference between a service and an application?
Between service and application. Oh, yeah. So service is basically providing a service defined by an interface. And an application can be a consumer of any particular service.
Okay. So a service is the communication part for the.
No, service is basically meant to be something reusable that implements some functionality that is interesting to different applications, whereas applications usually are very dedicated and solve a particular problem.
It's independent from the applications themselves, so it's designed separately from them.
Yeah, so the service in a vehicle could be the service that handles the door, raising or lowering the window, opening, closing the door. That is a service that is very generic and can be implemented on each and every vehicle. And now you can build an application in a generic way that can open or close doors remotely. So the idea is have reusable services defined by service interfaces as a use service, and then have specific applications that use these services.
Okay.
But that is not necessarily always the case.
Yes.
It's just we wanted to point that out explicitly, that there is a difference between these reusable services that are defined formally by an IDL versus applications that simply make use of these services.
Okay, I got it. Thank you.
I mean, I do have in principle a question, which is there also a error handling? Like, is there any catch of errors when if you have a mistake installing the firmware?
In my POC, no.
Yeah. But
in
exactly.
reality, there better be, yeah.
Exactly. So, but who would be handling
So-
the errors if there were
the application,
the application? Okay.
yeah. The firmware updater. So the
application
firmware
itself.
updater, of course, would need to implement some reasonable strategy like A/B partitioning or something and roll
But
back or swip back. But uProtocol only provides the means to communicate the errors. So Symphony would then see that something has failed and would retry it. But that is obviously not a really good strategy if the firmware cannot be installed, because you would repeatedly try to reinstall it, which will always fail. So at some point in time, somebody needs to be notified and stop this.
Okay, because that would have been my question if there was already a mechanism for that, but okay.
Yeah. Maybe AI can solve that in the problem in the
Okay.
future. I don't know.
Yeah, so like maximizing chaos. Is there any question from the audience? No question from the audience? Okay. Thanks a lot, Kai. Thank you.